back to California Geology. Today I want to talk about California deserts. And the definition of a desert is a region that sees high evaporation rates compared to precipitation rates. And usually the precipitation or the rainfall would be something less than 10 inches per year, 25 centimeters per year. Under that definition, if we think about Death Valley receives about really 3 centimeters per year of precipitation, which is about 2 inches. So it really should be 3 centimeters per year. And but evaporation, it's receiving basically a couple of orders of magnitude more evaporation. So it's a really dry place, extremely dry. Think about, if the water is being sucked out of plants, out of the ground, very high evaporation. If we look at rainfall in Los Angeles, the average precipitation per year is about 15 inches per year. So remember, 10 inches per year would be desert or arid environment. Up to date this year, in 2014 and 15, they've received about 6.42 inches. So they're not quite, they got till, I think, October to make up the other 3.5 inches to get above that 10-inch level. And then for San Francisco, in contrast, to see where we receive about almost 24 inches per year on average, and we're below that. We're at almost 16 inches so far in 2014-15 rain season. And then kind of thinking about that evaporation, right? So the evaporation is coming perhaps through groundwater. We get these salt pans forming here, no flowering plants, right? So Death Valley, high evaporations, really 3 centimeters per year compared to the rainfall. Now, what deserts are we talking about in California? So the general names we have for the deserts are the Great Basin Desert, and more importantly for geologists, we think of those as Death Valley, the Owens Valley, the Panamint Basin, the Mono Basin would be deserts. So those are these regions in the Great Basin Desert. This extends out through Nevada and into Utah. Now the Mojave Desert, that's strictly California's, and so it's more of a wedge-shaped triangle here where there's a fault line here called the Garlock Fault, and then the San Andreas Fault will be here. But here is a desert, the Mojave Desert, and then stretching for basically the Salton Sea area and the San Jacinto Mountains down here in Southern California to the Colorado River would be this Colorado River Desert or the Colorado Desert. So we have 3, the Colorado Desert, the Mojave Desert, and then the Great Basin Deserts up here. Some smaller ones, sometimes we talk about, oh yes, I forgot about this. Just a couple of years ago, I was looking around for the hottest place on Earth, and I had read that there was this place in Libya. In fact, El Azizia, Libya, had the record in 1920 for the highest recorded temperature of 136.4 degrees Fahrenheit, 58 degrees Celsius. And but it was always kind of dubious. And I read an article how it was at an Italian field army post, and there was an inexperienced observer who didn't know how to read the instrument. And but of course, once that datum was put out, that information was put out, that became the hottest place on Earth, the hottest recorded temperature. But in 1913, in July of 1913, Death Valley recorded a temperature of 134 degrees. And so that has been the highest temperature in the United States or the Western Hemisphere. However, just a couple of years ago, that dubious temperature from Libya was overturned by the World Meteorological Organization after a pretty detailed investigation, looking at the old log books, the actual real log books they found at the Italian post. And they realized that there was an anomaly, that something was wrong. So they think the temperature was off by maybe 7 to 8 degrees, which makes Death Valley the hottest place on Earth. So here in California, not only we do have the highest mountains in the 48 states, the lowest point in the 48 states, we also have, obviously now we have the hottest temperature, not just in North America, but in the world. Now, what causes deserts in California? And so one unusual thing about the deserts in California is we we're really out of the zone of this of where you'd expect to find deserts. So if you think about global circulation patterns, we see warm air rising at the equator, at the tropics, creating low pressure. Whenever we have low pressure, we see precipitation, rainfall. And then that air mass, or those air masses, will move to higher latitudes, around 30 degrees north or south latitude, and begin to descend. And when they descend, you form high pressure, which causes dry conditions. So at 30 degrees latitudes, we call these the horse latitudes, but also they're known as desert fronts, because this is where we expect to get desert climates. And if we look around the world, the 30-degree north latitude, the Sahara Desert, the Arabian region here, outback of Australia, Kalahari of South Africa, Altiplano of Argentina, and the American Southwest. Although if we go up here to California, we have deserts, but they're a little bit farther to the north. Kind of the same things happen over here in the Gobi Desert, and it's related to mountain ranges. So our deserts here in California are mostly due to mountain ranges. And we call that process the orographic effect. So oro is a Greek word. Oro, it means mountain. So a mountain geography, right? A mountain geography effect. So what happens is the air masses coming from the Gulf of Alaska over the Pacific Ocean, that moist air, when it gets to California, it has to get up over the high Sierra. When it does that, it goes to higher elevations where there's less pressure, and the lower pressure, the water, basically the clouds cannot hold on to the water, and there's precipitation. So on the west side of the mountain range, we have this orographic effect where we see abundant rainfall, snowfall, big rivers, American Stanislaus River, large river systems coming down on the west side of the range. But then as soon as the air mass makes it over the mountain range, then we get something called the rain shadow. So I want you to differentiate the rain shadow from the orographic effect. So the orographic effect deals with the rainfall on the west side. But now that air has to descend. And when it descends, just like in the global circulation pattern, we're going to see high pressure. And so this high pressure will lead to evaporation from this compressing and warming air. If you ever pumped a bicycle tire up with a pump, and as you're pumping that pump, if you feel the pump after a few pumps, it gets hot because you're compressing that air in that bicycle pump. So the same thing is happening here. When that air descends, there's compression, which causes warming and evaporation. Now, the next question is, which mountains cause the orographic effect for the California deserts? Now, for the Great Basin deserts, or the Basin and Range region, it's a Sierra Nevada. So the storms come up over, they get over the Sierra, and they drop down into the Owens Valley, the Panamint Valley, Deep Springs Valley over here, and into Death Valley. So Death Valley is extremely dry because those air masses have already gone over the Sierra Nevada. The White Mountains, which also are around 14,000 feet in elevation, the White Mountains and Inyo Mountains right here. And then the Panamint Range, Telescope Peak, is over 11,000 feet. So those air masses that have been really stripped clean of all their water. By the time they get to Death Valley, they're extremely dry. Now, for the Mojave Desert, because the air masses off the Pacific coast do a counterclockwise circulation, if you ever look at the storm patterns, they're coming in this way. So as the air mass comes in, as they're going over these transverse ranges, the San Gabriel Mountains over here, San Bernardino's down over here, Santa Susana's. So as those air masses come up here, they have to go over these transverse ranges, and that's what causes the arid evaporation environment here in the Mojave Desert. Then for the Colorado Desert, those air masses have to get over the peninsular ranges. So peninsular ranges cause the deserts in the Colorado Desert region. So it's Sierra Nevada for the Southern Basin and Range, or the Great Basin deserts, the transverse ranges for Mojave, and then the peninsular ranges for the Colorado Desert. If I ask you what range is causing the rain shadow for Death Valley, then it's the Sierra Nevada. And it's also these other ones, but the main one is the Sierra Nevada. Now there's a mini rain shadow over here in the western Central Valley. In fact, we call it the Western Great Valley, because those same storms have to get up over the Coast Ranges. And so there's very little precipitation on the west side of the Central Valley. We'll see it mostly over here on the east side, and then obviously as runoff from the Sierra Nevada.